I would like to introduce to you Vanessa Castro.
All right, perfect. Good afternoon, everyone. As Michaela said, my name is Vanessa Castro, and I am the product specialist for Belimo's Zip Economizer product. Before we get started today, let's heed someone's warning about diving into laws. Otto von Bismarck, also known as the Iron Chancellor, once said that the man who wishes to keep his respect for sausages and laws should not see how either is made. With reference to the laws, and in our case, codes and standards, a knowledge of how they're made may increase our respect for them and their makers. And well, if it doesn't, we can hopefully express our discontent for them in a more intelligent manner. Now that we've heeded his warning, current energy codes are being driven by the continuous need to reduce energy consumption throughout the world. Energy use in buildings makes up a very significant piece of the pie for the U.S. total usage. According to the Department of Energy, nearly 5 million commercial buildings and over 100 million residential households in the U.S. consume over 40% of the nation's total primary energy usage. And buildings, well, they consume about 70% of electricity alone in the U.S. Building energy codes are a critical component of the effort to curb the ever-growing impacts of building energy use. But why should we care about economizers and how they can affect this? For many individuals, the rising cost of energy makes it uncomfortable for them to sustain a comfortable, conditioned indoor environment. Building energy codes set a minimum efficiency boundaries that bring along vital, tangible benefits. Not surprisingly, better codes mean better benefits. Recent research shows that if building energy codes were upgraded to be 30 to 50% more stringent among adopted states and effectively implemented, excellent progress would be made in the areas of energy consumption, energy cost savings, and CO2 emissions. In reduced energy consumption, it would be equivalent to the power generated by 260 medium power plants. For rising cost savings, it would be more than $4 billion per year back in homeowners' pockets. And as far as reduced CO2 emissions, by roughly 3% in terms of the projected national CO2 emissions for 2030. Now, codes go without their challenges, despite their clear benefits. First, you have code development, reaching consensus on their details. Code adoption, it's not automatic in many states. Code compliance, implementing and learning to design using these new standards and techniques. And my personal favorite, code clarity. Interpretations of code sometimes gets the best of many of us. Luckily for us, there are three that we'll be highlighting in today's webinar. ASHRAE Standard 90.1, the International Energy Conservation Code, California Title 24, which is a state code for the state of California. Now, of course, there are many others that we can discuss, but these are the three that are most commonly adopted. We can all agree that weather and climate have a major impact on the energy use in commercial buildings. Energy codes and standards rely on a clear definition of climate zones to convey requirements to these builders. However, prior to 2004, there was no single agreed-upon climate zone map for the United States for use with building codes. So how does one go about dividing the U.S.? Maybe they could have done it by regional nicknames and territories. Actually, maybe they could have done it by time zones, as there is more of a similarity between regions for this, but then how would they have done for daylight savings time on this? Ultimately, in the early 2000s, researchers at the U.S. Department of Energy's Pacific Northwest National Laboratory prepared a simplified map of the U.S. climate zones. The map was based on analysis of over 4,000 weather sites. They divided the map into 8 climate zones based on temperature, precipitation, and heating and cooling degree days. These zones are hot humid, hot dry, mixed humid, marine, cold, very cold, and subarctic. Additionally, it was divided into 3 moisture regions: marine, dry, and moist. Thus, this map now allows us for up to 24 potential climate designations. The new climate zones were set along county, not state boundaries, making it easier for builders to determine what climate zones apply to specific buildings. This climate zone first appeared in the 2004 IECC supplement, as well as an ASHRAE standard 90.1 2004, which we'll cover in a bit. So why are economizers important to regulate with codes, standards, and why should we care? According to the U.S. Environmental Protection Agency, or the EPA, it states that Americans on average spend approximately 90% of their lives indoors. And to make matters worse, they also state that the concentrations of some of the pollutants are 2 to 5 times higher than typical outdoor concentrations. Now that we understand the reason and benefit why these codes and standards exist and why economizers should be governed by them, according to the table above from an ASHRAE study, here are some of the baseline energy savings to be had with proper economizers, not just those that are not working, which many exist in the field. As one can see, all the climate zones are represented in this table, and more importantly, they all see benefits to economizers, ranging from a 24.9% energy savings in Denver to 16.3% in New York City. The entire country, regardless of their climate, can benefit. Everything evolves over time, and changes based on the needs of society, as well as codes, are no different. Currently, the IECC 2012 version and the ASHRAE standard 90.1 2013 make up the latest baseline codes and standards. Though as always, further code versions are always being developed. The IECC, or the International Energy Conservation Code, was created in 2000 by the International Code Council. It addresses energy efficiency on several fronts, including cost savings, reduced energy usage, conservation of natural resources, and the impact of energy usage on its environment. The IECC applies to both residential buildings and commercial buildings up to 3 stories in height. This includes measures to improve their thermal envelope, HVAC systems, and electrical systems of these buildings. It is updated every 3 years, and the most current version available is IECC 2015, but the 2012 version currently is the one that is most commonly adopted. The climate zone map above highlights the climate zones that did not require economizers according to the 2006 standard, as well as the size of the units that required them. As we can see, there were several regions that did not require economizers, because at the time it was not believed that their initial cost was offset by the energy savings from them. This area in 2006 accounted for more than 25% of the United States. In 2009, the air economizer was required for all cooling systems with a cooling capacity exceeding 54,000 BTUs per hour, dropping the unit size from 136,000 and 54,000 as it was in 2006. Additionally, it set the high limit of 480,000 BTUs for buildings without an economizer. Economizers were not required in climate zones 1A, 1B, 2A, 2B, 7, and 8. These climate zones represented extremely hot or humid areas where, again, it was believed that the first costs of the economizers would not be offset by their energy cost savings. In 2012, an integrated air economizer solution was required for all cooling systems with cooling capacity exceeding 33,000 BTUs per hour. Economizers were not required in Climate Zone 1. Important to note, this was the first mention of an air economizer undergoing functional testing in order to determine and verify that they function according to the manufacturer's specifications. Now, a little bit about demand control ventilation, or DCV. A DCV system controls the amount of outside air brought into the building. It should provide the amount of outside air the human occupants need and no more. This accomplishes 2 main things. First, it saves energy by not heating or cooling unnecessary quantities of outside air. Second, it can provide assurance that sufficient outside air is being supplied to the occupants. Fixed ventilation systems provide constant, sufficient fresh air. With regards to an economizer, in its simplest form, as CO2 levels decrease, the damper closes past ventilation minimum position and moves towards DCV minimum position. Again, it closes the outside air damper beyond that minimum position when CO2 levels are below set point. Understanding a little of the background of demand control ventilation allows us to understand the transition in these requirements. As the revisions have been made throughout the years, requirements have increased for spaces larger than 500 square feet. From 2009 to 2012, the requirements for average occupant load went from 40 people per 1,000 square foot to 25 people per 1,000 square foot in 2012. In the timeline above, you kind of see a summary of the changes related to IECC for both the economizer and integration of demand control ventilation systems. The lowering of the tonnage requirements from 11.25 tons to less than 4.5 ton units allow for more economizers to be placed in areas where they can see the benefit. Additionally, the allowance of many climate zones to include economizers also assist in that endeavor. In 2009, you can see demand control ventilation finally being incorporated into the IECC codes, as well as the drop from 40 people per 1,000 square foot to 25 people per 1,000 square foot. Now, a little bit about ASHRAE Standard 90.1. ASHRAE Standard 90.1, also called the Energy Standard for Buildings Except Low-Rise Residential Buildings. Its purpose is to provide minimum requirements for the energy-efficient design of buildings, except for low-rise residential buildings. 90.1 again applies to commercial buildings, including multifamily high-rise buildings. It's also updated every 3 years, and the most current version available is ASHRAE Standard 90.1 2013. Very similar to the maps and designations we saw in the IECC code, ASHRAE Standard 90.1 also has the requirements for economizers to be both size and climate dependent. ASHRAE Standard 90.1 in 2004 had the most lenient code separation as you see in the illustration above. Climate zones 1, 2A, 3A, and 4A did not require economizers, again, over 25% of the United States. This ASHRAE standard in 2004 was very similar to the separation which was seen in IECC in 2006. The purpose of the high limit switchovers are designed to disable the economizer when its use would increase the energy used by the cooling coil. In other words, when the cooling return air would use less mechanical cooling than cooling the outdoor air. With that in mind, ASHRAE Standard 90.1 designated high limits based on climate zones. In 2004, there were 3 particular high limits, 65 degrees, 70 degrees, and 75 degrees, all designated to a particular climate zone. In 2007, the division of climates was switched to be more on a moisture region dependent, as the division in tonnages from units can be seen from 65,000 to 135,000 scattered the U.S. to the values above, more in line with the moisture division line. Again, across the board, we saw climate zones 1, 2, 3, and 4 did not require economizers. So although the division was made on tonnages, it was not made to alleviate the requirements. Now in 2010, the placement and the divisions of the zones that we know exist today. The BTU and tonnage of systems dropped from 54,000 and 4.5 tons across the board. Additionally, the only region that does not require an economizer is Climate Zone 1, whereas in 2007, Climate Zones 1 through 4 did not require them. This, of course, opens the market up for new installations with hopes of better, more efficient economizer units. With regards to the high limit, ASHRAE eliminated the old 65 degrees set point that existed for many zones and just incorporated 70 degrees and 75 degrees respectively. This opened up the window of opportunity for extending economizer hours through these climates. As the revisions for economizer requirements changed in ASHRAE, so too did the revisions for demand control ventilation. As the revisions had been made, the requirements had increased for spaces larger than 500 square feet. From 2004 to 2010, the requirements for the average occupant load went from 100 people per 1,000 square foot to 25 people per 1,000 square foot. In 2004, the design occupancy density was for 100 people. 2007, the design occupancy was designed around 40 people per 1,000 square foot. And in 2010, the requirement was for 25 people per 1,000 square foot. ASHRAE's main initiative, as we look at the timeline of changes, from 2004 to 2010 was to see a 30% reduction in energy savings for their standard. Now, with these changes being made, you can see that they went through above and beyond items in order to make sure that these energy standards were met, including more climate zones into the requirements for economizers, as well as the tonnage requirements for them. Additionally, taking into account the occupant design load from 100 people to 25 people per 1,000 square foot. Every state can adopt codes and versions at their own pace. As I mentioned earlier in the webinar, when talking about code adoption as a problem with codes, the code adoption is not automatic in most states. Without a statewide adoption, local jurisdictions are left without much state guidance or resources, and builders on the ground will face a very confusing mishmash, if you will, of codes across their region. Additionally, even with state adoption, there is no consistency with code revision levels and code year adoptions for every state, which for some companies that cover a variety of states and a variety of territories can create a headache of different revisions and policies. However, some states have adopted their own codes and standards to follow. So one state in particular for that is California. The California Energy Commission is California's primary energy policy and planning agency. Created in 1974, the Commission has the responsibility for activities that include forecasting future energy needs, promoting energy efficiency through appliance and building standards, and supporting renewable energy technologies. One of its most prominent responsibilities is the maintenance of California Energy Code. The Energy Commission's energy efficiency standards have saved Californians more than $74 billion in reduced electricity bills since 1977. $74 billion. These standards conserve electricity and natural gas and prevent the state from having to build more power plants. The savings are calculated by determining the energy savings associated with a more energy efficient building, with a more efficient building standard or appliance. The Commission's main goal is that by 2030, all new commercial construction in California be zero net energy. Now, the CEC faced a very similar problem when trying to correlate the largest state in the U.S. into climate zones. The ASHRAE map on the left shows 5 climate zones, whereas the picture on the right, which reflects California Energy Commission's map of California, reflects 16 different climate zones. The microclimates in California have mandated the expanded climate zones in order to assist for expanded energy savings. In 2008, the requirements for economizers were 75,000 BTUs per hour, or about 6.5 ton units. In 2013, what they did was they also dropped the units. In 2013, changes were made that a thermostat with 2 stages of cooling were added for single zone systems whenever an outside air economizer unit was present. This allowed for integrated economizer operation. It also increased energy savings by making the baseline for economizers from that 6.5 ton unit requirement to about 4.5 ton unit requirement, Additionally, if we go back to our conversation regarding high limits, we've expanded the high limit requirements to be very specific based on climate zones, ranging from 69 degrees Fahrenheit to 75 degrees Fahrenheit in 2013, whereas in 2008, it was only 75 degrees Fahrenheit or 70 degrees Fahrenheit. Now, with differential dry bulb, they've also taken into account the variety of changes and offsets that would be needed for this. In 2004, the requirement was that outside air be greater than your return air. But in 2013, it took into account different offsets for these climate zones, really honing in on the energy savings and being microclimate specific. Now, California Title 24 expands far beyond different items. It also requires that economizers have the following features. It requires that the economizer have a 5-year manufacturer warranty of the economizer assembly. It required that suppliers of economizers shall certify that the economizer assembly, including but not limited to the outdoor air damper, return air damper, drive linkage, and actuator, have been tested and are open and closed against the rated airflow and pressure system after 60,000 damper opening and closing cycles. It ensures that economizer and return dampers shall be certified to have a maximum leakage when tested in accordance to AMCA standard 500. It requires that if the high limit control is fixed dry bulb or fixed enthalpy fixed dry bulb, then the control shall have an adjustable set point. Regarding sensor accuracy, it required that outdoor air, return air, mixed air, supply air sensors shall be calibrated with the following accuracies above. It requires that the data used for control of the economizer shall be plotted on a sensor performance curve. It also required that sensors be used for the high limit control shall be located to prevent false readings. This includes, but of course is not limited to, being properly shielded from direct sunlight. Finally, it also requires that relief air systems shall be capable of providing 100% outside air without overpressurizing the system. Now it goes way beyond this. All newly installed economizer units shall be equipped with fault detection and diagnostic systems according to the subsection that's listed above from the code. This ensures that the system is working according to standards. It includes alarm coding, manufacturer approval, as well as advanced testing requirements to ensure that fault detection and diagnostics exist within the economizer, ranging from the displaying the values of the sensors to indicating the different conditions from free cooling to economizer to compressor enables, as well as making sure it can read and detect the following faults. Again, in their world of beyond economizing, they also require functional testing for the units before the techs leave the roof, ensuring that the economizer is fully functioning and integrating with the system. A sequence of operations of tests that need to be done in order to ensure compliance. Now that we've covered a little bit about different codes and standards, how would one go about finding this high limit changeover temperature and trying to be compliant with these codes and standards? As we've seen, they continue to change with years. If we were outside of California, you may need a copy of 90.1. You will need a copy of the climate zone map, a copy of one of the tables with those high limit temperatures, and on a bad day, you might need a psychometric chart. Hopefully none. Again, I did not cover psychometrics in this webinar. But with Belimo's Zip Economizer, the way you find your high limit changeover temperature is by just knowing your zip code. Plugging in your zip code, you are automatically compliant with codes. Now let's take a look at a particular example. Zooming into the region, you can see that there's a lot of zone overlap within a state because, as I mentioned earlier, the borders are with counties, not within the state. However, with the Zip Economizer, plugging in your zip code will show you exactly what climate zone you're in, and more importantly, what that temperature set point is. Now, just don't take my word for it. This is the exact table from that high limit chart. And as I mentioned earlier, California and their sequence of operation test, our ZIP Economizer has those acceptance tests built right into it. By going into our Economizer test menu, pressing OK, we run through the sequence of events and the sequence of tests that are required for the state of California, but also important for every state to know that economizers are fully working and functioning before they leave. We open the damper, confirm that a damper did open, turn on our compressor, confirmation that the compressor did run, close the damper, confirmation that the damper went to minimum position, and then confirm that the damper fully closed. And then you know that the economizer test is final and verified. Again, final verification, visual verification that your economizer is up and going. So what would you like in your RTU based on what you've learned today? Thank you.
Thank you so much, Vanessa. During your presentations, we did get a couple of questions, so I will ask them, and then hopefully you can answer them. Sound good?
Sounds good.
Okay. This individual states, hello, I work for a large university with many air handling units, both new and old. Does the code in California call for minimum outside air requirements for the old units? Some from 1960, as well as that, weren't initially designed for OA minimums. Also, if outside air is controlled by CO2 sensors, is a minimum OA still required?
Okay, so I will tackle the second half of that question first. And my apologies if I don't cover the full question. Feel free to email us after this webinar. Michaela will give out the email as to how to reach us post-webinar. Regarding your minimum positions for CO2, you would still require 2 minimum positions, one for your ventilation minimum position, as well as one for your demand control minimum position. This is to ensure that you're going to the correct set points depending on your occupancy levels. And with regards to California state, California requires it for new installations. In order to be compliant with certain rebates, then you would need to be compliant that way. So I hope I answered your question. If you're looking for something a little more specific, feel free to give us an email afterwards.
Okay, and just for your reference, that email is going to be marketing@us.belimo.com. On to the next question. WRT fault detection. Where are operating engineers in this regard? As a whole, are building operators receiving guidance on how to relate to fault codes? Is there a commissioning standard to assure that the building operator is fully integrated with receiving and dealing with fault detection?
I will interpret that question as best I can. Right now, the way California, in this case, for fault detection diagnostics is written, that the faults have to be available to be displayed. Currently, for our unit, for example, the SIP Economizer, you can see the displays on this screen. We also have remote alarm indication that can be wired back to a thermostat if it has remote alarm input, as well as to a light or a buzzer or another dry contact switch to your fitting to show that there is an issue with the unit, not necessarily that what the particular fault is. Additionally, in terms of the fault codes and diagnostics, California does have a variety of code buckets, if you will, fault buckets that you need to make sure you at least comply with and can cover. The ZIP Economizer has over 30 different faults and alarms that can be shown, and we do have a fault detection and diagnostics guide that lists all of those 30 standards, all of those 30 faults, as well as their particular code bucket designation.
Okay, next question. This individual works for Trane. We use Belimo valves on our equipment. Would one expect to see these Belimo Economizer controllers factory mounted?
That is our goal, yes. We'd love to see them factory mounted across many different rooftop units. We are working with many OEM partners in order to confirm and install those mounted. Further information, please feel free to contact us.
Okay. Next question. How is it useful for the rest of the world?
How is it useful for the rest of the world? Good question. ASHRAE standards also ASHRAE standards also provide guidelines for the rest of the world. For example, a lot of our South American partners and customers utilize ASHRAE standards in order to designate different items, for example, in Sao Paulo, Rio de Janeiro, because they have corresponding ASHRAE climate zones. So they can still use the zip economizer, even though we can't put in, for example, Brazilian postal code, but we can give them their corresponding region's postal code to put in.
Thank you. Next question. What is the requirement for the minimum OA position when using CO2, DCV?
So one thing I did not cover in this webinar is ASHRAE standard 62.1. 62.1 is the governing code standard when it comes to ventilation requirements. I would defer for you to review 62.1 and provide the standards from there.
Okay, next question. Does BELIMO help close the gap between design and practical operations? Commissioning is often lip service at best. The building crews need programmed follow-up to ensure that they are up to speed in all respects. Programmed in that there needs to be a prearranged visit by BELIMO built into the design product.
Well, we do have a variety of different regional application consultants, as well as our sales managers scattered throughout the U.S., as well as in South America. And if there's a particular site or building or retrofit, for example, that requires more attention or would like additional assistance with, please feel free to contact your local BELIMO person, either your regional application consultant, who does work with many specifying engineers, or as well as your local BELIMO DSM.
Okay, if there's any further questions, feel free to ask them at this point. After the webinar ends, if you find yourself thinking or wondering about more questions, feel free to email us at marketing@us.belimo.com and we will surely get back to you. And this is the final question. NCA, ventilation cooling, or free cooling is an option with central systems to meet energy efficiency requirements in residential. Are the testing requirements the same as commercial?
I believe so. They're a little different. I would have to double check. I'm not very familiar with the residential code, unfortunately, but I can follow up with that individual and get back to them.
Okay, well, as I said, we did take our last question. If you should have any further questions or any questions in regard to any of our BELIMO products, feel free to send us an email at marketing@us.belimo.com. If you joined us halfway through the webinar was recorded so that you can review it at a later time. And if you have any further questions, again, feel free to contact us. Thank you for visiting and attending the BELIMO webinar series. I hope you all have a wonderful day. Thanks so much.